So hello everyone. Today we discuss about the worksheet oxidation number 1. Actually, there is a 3 worksheets are there. So today we discuss the total 3 worksheets which are having a different procedure. Okay. See the second one, the oxidation state, the oxidation number of sulfur in S8 molecule, S2F2 molecule, and H2S. So we know that any molecule or any element's oxidation number, it's a free state. Free state means it is not having bonds with any other elements. Okay, we know that oxidation number means oxidation state, the charge gained, the charge acquired by an element in a molecule is mainly due to the electronegativity difference between that atom and to the other bonded atom. Someone gains electrons, someone loses electrons. That's why, therefore, there is a difference in the electronegativity. But in the same molecule, means the molecule which are having the same elements, the atoms of same elements, so there is no change in the electronegativity. So the oxidation number of S8 is 0. Okay, it's a free element. Next, in S2F2. What is the oxidation number of sulfur? Have to calculate. So we know the procedure 2x plus always fluorine is always -1. Is there what is the any other possibility for fluorine? No. For fluorine only -1 oxidation number is possible because it is the most electronegative element among the all elements. It is ready to accept, it is ready to take the electron from all elements. When it is free state, it's okay. In F2, its oxidation number 0. But in the formation of molecules, in the molecules it always gains electron from other elements, always shows +1 oxidation state only. So the overall charge is 0. So here we get it's equal to +1. Sulfur oxidation state is 1. Next, if you see H2S, you know that the hydrogen oxidation number is also +1. Okay, only in the hydrates, metal hydrates only, like sodium hydroxide, sodium hydride, potassium hydride. Like in metal hydrates only, hydrogen shows a -1 oxidation number. In all other cases, hydrogen shows only +1 oxidation state. So hydrogen +1 to 1 plus, so here x equal -2, means the sulfur oxidation state here is -2. Okay, next see the question number 6. Okay, see the question number 6. What is the oxidation state of nickel in NaCO4? Oxidation number of nickel in nickel carbonyl. Okay, nickel carbonyl. So here it is a complex compound, nickel carbonyl. Okay. So here we know that how to find the nickel oxidation state. So take it X. Next, what is the carbon monoxide? Carbon monoxide oxidation number is always taken as 0. Overall charge is also 0. X equals 0. Means nickel oxidation state is 0. Okay. Here main important thing. I will give some extra points about this, nothing but extra ions, which are shows 0 oxidation number. Mainly it helps in the calculation of oxidation number of metals in the complex compounds. So you can write a note here. So which ions shows different oxidation numbers. For carbon monoxide you have to take 0, H2 have to take 0. For in the complex compound you have to take NH3 also 0. So these are the main components shows 0. Sometimes so NO also shows 0. There is a possibility of NO plus. If NO is given this individually means if NO power is not given anything, we have to take it as 0. Sometimes NO also shows +1, so it will be given as NO power plus. This is called nitrosyl ion. And we know that cyanide ion, Cn minus, okay, SCN minus, thiocyanate. Next Cl having minus, F minus, Br minus, I minus, and SO4 will have to take minus 2. Okay. Next for PO3, PO4 will have to take minus 3. Okay. Phosphate. Sometimes the questions are having oxalate C2O4. Oxalate having a minus 2 oxidation number. Next cyanide. So these are the main examples comes in the complex compounds. Okay. Next, what is the oxidation state of oxygen in potassium superoxide? So potassium superoxide. Potassium superoxide. So what is the formula of potassium superoxide? So first I will say about superoxide. We know that general oxygen oxidation number is minus 2. So generally oxygen shows a minus 2 oxidation number in all oxides. Okay. In general oxides, oxygen shows minus 2. But in rare cases, that is in peroxides, O shows minus 1. So this O minus 1 can be written in terms of O2 minus 2. So nothing but each oxygen getting minus 1. So this type of are known as peroxides. If oxygen will get minus 1 by 2, if oxygen will get minus 1 by 2 or nothing but O2 power minus 1. O2 power minus 1, nothing but each oxygen having minus 1. This type are known as superoxide. Here it is given what is the oxidation number in the question. What is the oxidation number of oxygen in potassium superoxide? Superoxide nothing but O power minus 2. Okay, now we give the what is the superoxide formula is OKO2. So potassium always plus 1. So at like when fluorine shows only minus 1 oxidation state in the molecules. Potassium, not only potassium, all 1A group elements, lithium, sodium, potassium, rubidium, cesium, francium, shows only plus 1 always. It's a rule. Next, there is no other choice for them. Next, secondary group elements, beryllium, magnesium, calcium, strontium, barium, radium, they also shows plus 2 oxidation state only. Here potassium plus 1 kabatti, we have to calculate it for oxygen. So 1 plus 2x. So here x equal to minus 1 by 2. At each oxygen, we are taking 2x means 2x equal minus 1 means the total O2 is having minus 1. So each oxygen carries minus 1 by 2. Okay. Okay, next see the 10th question. So in the 10th question it is the given, the question is what is the oxidation number of phosphorus? So oxidation number of phosphorus in barium dihydrogen phosphate. Barium hydrogen phosphate. So I have to calculate the oxidation number of barium. Phosphorus is given phosphorus. So barium. So already we said the barium is a secondary group element. So it always shows plus 2 oxidation number. There is no other choice for it. Barium plus 2. 2 hydrogens and taken to the total 4 hydrogens are there. Each hydrogen 1. So how many phosphorus taken to 2 phosphorus are there? So 2x plus put to the 8. 8 oxygens power minus 2. Each oxygen carries minus 2 in general oxides. There is no overall charge. No overall charge equals 0 means 2 plus 4 minus 16. So here we will get 6. This means the phosphorus is having a +5 oxidation state. So actually it is the maximum oxidation number of phosphorus. Maximum oxidation number of phosphorus. How you say means the phosphorus, if you know configuration, phosphorus 15. So 1s2, 2s2, 2p6, 3s2, 3p5. What is the maximum number of valency electrons in it? The valence electrons, the maximum number of valency shell is only 5 electrons. So just remember, the oxidation number of an element does not exceeds its number of electrons in its valency shell. And a valency shell lo n electrons that is only its maximum oxidation number. Below that electrons, below that number, any oxidation numbers are possible out there. But more than valence electrons it is not possible. And the phosphorus ki maximum oxidation number that is only +5. Okay. Let's see the next one. So I think it is okay, nothing but 11th one. So 11th one, what is the oxidation number of iron? So oxidation state of iron in brown ring. In brown ring complex. So in the question, in the worksheet provided to you, the formula is given, but sometimes it is not possible that to give the formula. Just they simply ask what is the oxidation number of iron in brown ring. So what is the formula of brown ring? So what is the brown ring and what is this formula we see now? Actually it is a complex compound, that is FeH2O taken 5. You have to remember this also. So this is called brown ring formula. Actually this brown ring formation is a test for the identification of nitrate ion. For the identification of nitrate ion, it is a test. So if a compound, okay, if a compound in the brown ring test, the itself test name is brown ring test. A brown ring test law. There's some reaction is there. We do the reaction with salt is there. Okay, salts low nitrate unda ledo we have to find out. We do that best test to identify the nitrate is present or not. That is called the brown ring test. This is called brown ring test. Why it is called brown ring test? Ante that low manaki ichina salt ni we made it salt solution with water and adding some ferrous sulfate solution and add some amount of H2SO4. So in that what happens if we do the reaction in a simple test tube. So what happens in the reactions after mixing all that all the components? What are the components? Given salt, made it to salt solution with water and adding ferrous sulfate fresh solution. Next concentrated, highly concentrated H2SO4. So on this what happens? Here there is a formation of a ring takes place. Here there is a formation of ring. Okay, it appears just like a ring. So below one type of solution is there, above one type of solution is there. So a ring is formed, that is called a brown ring, and it is a complex compound. Okay, means so what is that formula means? The brown ring formula is this. We have to calculate the oxidation number of iron in this complex, that is X, with the H2O oxidation number overall 0. NO given as +1, for SO4 -2, that is 0. So here, so NO plus is given, okay. SO4 -2 here Fe. So it's equal to 1. Okay. Okay, here the iron shows a +1 oxidation number. So generally it takes place in very rare cases. because iron shows only normally +2 and +3, but here in this brown ring complex iron shows a +1 oxidation number. Okay, see the next one. So what is the oxidation number? What is the oxidation number of carbon in CH2O? So what is CH2O? So here CH2O is known as formaldehyde. It's called formaldehyde. It's called formaldehyde. So it is also known as HCHO, or it can be written as H1C-OH. Means it is having an aldehyde group, aldehyde functional group. I have to calculate the oxidation number of carbon. So calculation, there is no change. This is a normal method. 1x, hydrogen always carries 1. Normal oxygen having -2 overall 0. So x plus 2 minus 2. So here the carbon's oxidation number in formaldehyde 0. So carbon in many compounds are there. Carbon shows 0 oxidation number. If you calculate it for glucose, C6H12O6, fructose, C6H12O6, and even in the sucrose, C12H22O11, in all these compounds carbon shows 0 oxidation state. Okay, next see. Let's see the question number 14. So what is the oxidation state of chlorine? What is the oxidation of chlorine in HOCl? So what is the importance of this reaction is, this compound is so generally we know chlorine shows -1 oxidation number. Chlorine shows -1 oxidation number as it is a 17th group element. So 17th group element, it is having 17 electrons in its totally 17 electrons. Where initial there is 7 electrons are there. By getting 1 electron, it becomes nearest noble gas, that is argon configuration. Okay, but in this compound Cl shows a positive number oxidation number, that is +1. So how it is? This is known as hypochlorous acid. This is hypochlorous acid. So here HOCl, we know that OH generally carries OH -1. So OH -1 because we know that O -2, H +1. So this overall we will get OH-. So from now onwards, if you see the OH in any formula, you can write simply -1. Okay, now we have to calculate the Cl's configuration. -1 for OH carries -1 plus x equals 0. So x equals plus means Cl is carrying a +1 oxidation number. Let's see the question number 17. So a reaction is given bromine to BrO3 minus. So what is the change in the oxidation state? We have to find the change in the oxidation number of bromine atom. Atom is dash. So you have to compare. First we have to balance the reaction. Here 2 bromines are there, here only 1 bromine. We are comparing only bromines, so only try to check the number of bromines are equal or not. Here 2 bromines, here 2 bromines. Here what is the oxidation number of bromine? So that is equal to 0 because it is in free state. So oxidation number of bromine is 0. Here what is the oxidation number of bromine? So x 3 into -2. Each oxygen carries -2. Overall charge -1. So here x equal 5. So here it's oxygen bromine. Each bromine atom changes from 0 to +5. So what is if you want to write the total number of electrons change, then you have to write the 10, because each bromine changes from 0 to +5. Second bromine also having 0 to +5. But here the question is, what is the oxidation number change? It is not asked that what is the total number of electrons gaining or losing. Just it is asking what is the number, what is the oxidation state of each bromine atom. Means bromine atom K is 0 to +5 means the change in the oxidation number of bromine atom separately. That's why it is mentioned bromine atom. Bromine atom is 0 to +5. Next, see the question number 20. Okay, 18, 19 so looks very easy. Let's see what is the oxidation number of sulfur in Na2S4O6. Of sulfur in Na2S4O6. So we have to calculate for sulfur. So for sodium always there is only 1. 2 sodiums, this 4x plus 6 oxygens, it's -2. Okay, there is 2 plus here x equal to 2.5 means the average oxidation number of sulfur here is 2.5. We know that oxidation number, but oxidation state of elements may be 0, maybe positive, maybe negative, or maybe fractions. Okay, here its oxidation number is 2.5. Okay, see here what is the importance of this example is, so actually we calculated the sulfur oxidation number. It is exactly 2. We got the average oxidation number 2.5. So if you see the original oxidation numbers of each sulfur oxidation number is not 2.5. So if you see its structure, we will understand easily. So Na2S4O6 structure is like this. S double bond O, it's ONE. So actually it is the salt obtained from H2S4O6. In the place of H plus, 2 sodiums are occupied. So one sulfur again. So ONE. This is Na2S4O6. So here you see 2 sulfurs are connecting with the only sulfur atom. This sulfur also connected with right side sulfur, left side sulfur. This sulfur is also connected with the right side sulfur, left side sulfur. We know that if the same elements are, the atoms of same elements are bonded, there is no gaining, there is no losing of electrons. Means they exactly shares their electrons perfectly. No one gains more electrons towards itself. If electronegative difference is there, that is possible. But here the bonds are exactly between the same atoms of the same element. Kabatti here oxidation number of sulfur is 0. Its oxidation number of sulfur is also 0. So what is this sulfur oxidation number? It is having bonds with the oxygen this side. So this is 1, 2, 3, 4, 5 bonds. So we can't count this bond because this is the bond between the same atoms. Means this is having +5 oxidation state. In the same way this sulfur is also having, we don't count this bond because this is the bond between the same atoms. So here it is having the how many bonds? 1, 2, 3, 4, 5. So its oxidation number is also +5. Means what is the 4 sulfurs oxidation numbers are? +5, 0, 0, +5. So average here we got the directly 4x property, we got the average oxidation number, that is total 10/4, we got the 2.5. So as originally they are having oxidation numbers +5, 0, 0, +5. In sometimes options may be given like this also. Okay. Let's see the next worksheet, that is the oxidation number worksheet. Oxidation number worksheet 2. Okay. So let's see, it's a continuity one. See the question number 22. So here the reaction is given ClO minus plus SO2 forming Cl minus plus sulfur trioxide. We have to calculate oxidation state change in chlorine. So just like the bromine, here we have to calculate for Cl. So here what is the Cl oxidation number? So one chlorine is there. So what is the Cl oxidation number here is? O is -2. We have to calculate the oxidation number for chlorine, that is X. The overall charge. So remember, this minus is not exactly present on the Cl, not exactly present on the oxygen. It is present on the total molecule. This is present on the total molecule. Okay. So -1. So X equal to means X is having oxidation number +1. Here already it is directly the Cl -1. So that is Cl oxidation number -1. Means what is the change in the oxidation number is +1 to -1. Here we have to write the answer +1 to -1. Okay, see the question number 23. So what is the oxidation number? So oxidation number of chromium in CrO5. So what is the importance of this is known as CrO5. Name of CrO5 is chromium peroxide. Chromium peroxide. So actually, so if you see the chromium peroxide structure, so it is like this. There is one right side one peroxy bond is present, left side a peroxy bond is present, and there is a middle double bond present between the two atoms. Here importance is this chromium peroxide is the best example which appears two peroxy bonds in one molecule. Okay, we have many compounds, many peroxide molecules having one peroxy bond, but in this example it is having two peroxy bonds. Okay, one is right side, one is left side, and it is also having butterfly model of structure. So we know that a peroxy bond. So here important is it has two peroxy bonds. So what is mean by peroxy bond? So what is the meaning of peroxy bond is O single bond O. O single bond O is called peroxy bond. What is importance of this today? In the peroxy bonds, two oxygens are having -1. So here, how many peroxy bonds are there? Two peroxy bonds. This oxygen having -1, this oxygen having -1, because it is a peroxy bond. This oxygen also with peroxy bond already shows -1, -1. So this oxygen is a normal oxygen, it shows -2 only. So now we calculate for CrO5. So take X plus into that 5 oxygens, 4 oxygens are in peroxy bond. So for peroxy oxygens we write -1 only. So one is the normal oxygen, that is -2. Overall charge is 0. X equals 6 means chromium having plus 6 oxidation state. Okay, so like this some more examples are there, but here the time is to discuss the worksheets, but the different examples already we discussed in the class that is named as questions on oxidation number. We have a separate class that is questions on oxidation number. You can see that video also to know the more different examples. Okay. Let's see the question number 23. So what is the oxidation number of chlorine atoms? So oxidation number of Cl atoms in bleaching powder. So bleaching powder means to calculate the oxidation number, so it is compulsory to know for some compounds we must know about the structure of that molecules are also useful in the calculation of oxidation numbers. Okay, so how to know the formulas also perfectly. So bleaching powder formula is CaOCl2. If you calculate the normal method, so calcium is how much? Calcium plus 2 always, as it belongs to secondary group elements. O is minus 2x, overall charge 0. So 2x minus 2 plus 2 get cancelled. So Cl oxidation number is 0. So you can write Cl oxidation number 0. But here we did it combined, it means the average oxidation number become 0. But separately it is asked what is the oxidation numbers of chlorine atoms in bleaching powder. So we have to do separate. So separate oxidation number scale. We have to know the structure. Just like Na2S4O6. In Na2S4O6, on the general calculation we got oxidation number 2.5. That is average. So general calculation we will get the average oxidation number only. So each atom if you want to know the oxidation number, oxidation state, we have to know the structure. So what is the bleaching powder structure is there is Ca, OCl and CCl. With the help of structure only we can write the individual oxidation numbers. So we know that Ca plus 2, O is minus 2. So Ca plus 2, O minus 2, it's no change in it. So which is having the chlorine which is connected to the negative 1 shows plus 1, and the chlorine which is connected to the positive 1 it shows negative 1. So on average to direct 2x is we got plus 1 minus 1, that is equal 0. And then what is the chlorine's oxidation number is plus 1 comma minus 1. So we have to remember the chlorine which is connected to the negative 1, that is nothing but oxygen, shows the plus 1. The chlorine which is connected to the calcium, that is having minus 1 oxidation state. Okay. Next bleaching powders. I think see the bleaching powder question is not 23, it is the 24th answer. Okay, 23 was very simple. Next, see the question number 30. If 3 electrons lost by metal ion M plus 3, what is the final oxidation number of metal? So it's very simple. So but it is the first question of this model, so that's why we are discussing. So its normal position is m plus 3, it losing by lost by 3 electrons. So lost by losing 3 more electrons. So we know that so by losing electrons means they are losing negative charge. So they are losing negative charge means there is a domination of a positive charge will takes place. Only 3 positive charges are there, means already it is losing 3 electrons. Again it is given if 3 electrons again lost by m plus 3. So again 3 electron, 3 negative spike and 3 positives increases. Its final oxidation number state will be plus 6. Let's see the question number 35. So this is the oxidation state of chromium and KCrO3Cl. So it's a simple general method. Find the chromium, that is 1 plus x minus 6 minus 1. So minus 1 plus 1 will cancel, x equals 6. So chromium oxidation number maximum is noted that it is plus 6. Let's see the question number 38. The oxidation number of nitrogen in NCl3. I have to find the oxidation number of nitrogen. So you see here the oxidation number of what we will calculate for nitrogen. Just x plus 3 chlorines, one should having minus 1, overall 0, x equal to 3. So why it is given separately means there is a possibility getting the confusion in the nitrogen and chlorine, because both are having nearly same electronegativity. But in the NCl3 we take positive for nitrogen and negative for chlorine. Okay, so the nitrogen oxidation number is plus 3. So let's see the oxidation number. Let's see the worksheet. Oxidation number 3. Oxidation number 3 worksheet. Okay. Oxidation number 3. Actually, it is exercise 2. So here the first problem is very important, that is given. A compound contain X, Y, Z atoms, and given that the oxidation states of X, Y, Z are given plus 2, and this one minus 2. So plus 2 and minus 2 respectively. The probable formula, so find probable formula from the given option. So actually it is based on the options. So option load. So options choose, you have to check which is the correct one. But here we try to do directly. So we have to compare the options only. Without options we can't do, I think, because we have to compare these oxidation numbers in the given options. So first I see the options, then we proceed. Okay, see the next question in the oxidation number worksheet 3, exercise 2. There is a compound contain X, Y, Z 3 atoms. The oxidation number of X, Y, Z are given, then plus 2 and minus 2. I have to find the probable formula. Just have to check the formula which is in correct position. Correct position means which satisfies the oxidation numbers. Okay, see first we check the first one. So we know that any compound, we know that the compound must show total. The final oxidation number, there is 0. Okay, here what is the oxidation number of X? We are counting this. X is plus 2. Next other Y is also plus 2. So Z is 2. 2 Z's are there. Each Z is having minus 2. So that is 0. The plus 2 plus 4 minus 4 is equal 0. So it is looking a correct one. So we try next one also. Maybe there is more than one answers are also there. 2x are there. 2x means 4. 6 Z's are there. 6 Z's means 6 into minus 2. So minus 12. Next y2. Each 2 here is plus 4. So the means it is not equal to 0. Next x3. x3 means each x is 2. 6. Next y. How many y's are there? 4 to the 8 y's are there. Each y is having how much? 2. Means plus 16. Z2. So each z is having minus 2 means so minus 4. So it is also not equal to 0. Means it is not satisfied. So x3. So if 3 x's are means there is a plus 6. y2 means there is a plus 4. So z5. So each z is having a minus 2. So that is minus 10. So that is exactly looking same. So I think we are getting this option also. So check once again. So x is plus 2, y is plus 2. 2 z's are there. 2 z's means 2 z's means minus 4. So plus 4 minus 4 getting 0. It is also correct. Here 3x3. 3x's means 3 to just 6. 2 y's means 2 to the 4. 5 z's means 10. So this is also possible answer. Okay. Let's see. So what is the oxidation number? See the question number 5 in it. So oxidation number of molybdenum. Oxidation number of molybdenum in a complex compound is known as in its oxo complex. It was given as the oxo complex. The formula is given that molybdenum 2 O4 C2H4 taken 2 and H2O or given minus 2. So we have to calculate the oxidation state of molybdenum metal. So 2x, oxygen carries normally minus 2. So that's 4 into minus 2. You see C2H4. C2H4 is also having 0 oxidation number like water, overall minus 2. The 2x minus 8 is 2 plus 8. Okay. So the oxidation number of molybdenum here is plus 3. So no need to remember this complex because it is having a not a specific importance. So no need to remember the formula here. Okay. Next, see, I think the 6th question. Find the oxidation numbers of nitrogen in ammonium nitrate. Oxidation number of nitrogen, ammonium nitrate. So again, what is importance of this is here. This type of examples we calculate by separating this. So it is NH4 plus and NO3 minus. So because as it is an ionic compound, just there is attraction takes place between NH4 plus separate and NO3 minus separate. So we calculate the oxidation number separately. X plus 4 equal to 1, so X equal to minus 3. When nitrogen showing minus 3 oxidation number, so what is X? 3 oxygens, automatically minus 6. So X equal to 5. So it is having this example having the two importances. So what is the two importances means? Here we are calculating by splitting the compound as NH4 plus and NO3 minus, cation and anion. Next, one more importance is there. Here already we know the nitrogen shows many number of oxidation states. Okay, so the least oxidation number of nitrogen is minus 3. Okay, we know that nitrogen belongs to 15th group. It is having 5 electrons in outermost shell. By gaining 3 electron, it will get nearest noble gas configuration, that is neon. So minus 3, and it is having the total final how many valence electrons? 5. It may lose the 5 valence electrons showing plus 5. Means its least oxidation number is minus 3, its highest oxidation number is plus 5. That both are exhibited in one compound, that is in ammonium nitrate. One nitrogen shows its least oxidation number, one nitrogen shows its highest maximum oxidation number. Okay, next see one more question. That is question number 10. Okay, so what is the oxidation number? What is the oxidation number of vanadium? What is the oxidation number of vanadium in a complex given rubidium 4, sodium, the hydrogen, vanadium 10 atoms and O28. We have to calculate the oxidation number of vanadium. Okay, just we have to follow the general rules. So what are the rubidium? Rubidium belongs to 1A group, so its oxidation number 1 plus sodium also, 4 rubidiums are there. There is a 4 into 1 sodium 1 plus there is a 1 hydrogen 1, so 10 vanadiums Vx, 10 oxygens. 10 oxygen means 28 minus 28 is carrying minus 2. Okay, so 4, 5, 6. 10x minus 56 equals 0. So here so the oxidation number of vanadium is plus 5. So next see the question number 11. So the oxidation number, what is the oxidation number of platinum? So platinum in, it's a platinum complex, C2H4Cl3 all minus 1. How to calculate the oxidation number of platinum? Because platinum is a transition metal, they show the special property complex compounds X plus C2H4 always have to take 0. The Cl, each Cl carries minus 1, so it is minus 3. Sorry. So what is the overall charge? Overall charge is equal to -1. So X equals. So the platinum oxidation state is +2. So generally the platinum mainly shows +2 and also +4 oxidation numbers. Okay. Let's see the question number 14. What is the oxidation state of iron in Fe3O4? What is the oxidation state of iron? So this is also having a specialty. Here we can calculate the oxidation number of iron directly. That is take 3x, 4 oxygens minus 8. So there is a X is oxidation number. Each iron is having oxidation number 8/3. Okay. Next we can calculate in the other type. This is the first method. So it is based on the options. Okay. In the other model we split into two compounds. It's into FeO plus Fe2O3. Total say 3 irons, 4 oxygens. So like this we calculate its oxidation number. Here iron x minus 2 equals 0, x equal plus 2, 1 iron plus 2, here 2 irons, 2x minus 6 equals 0, so x equal 3, means one iron is having plus 2 position, other iron is having plus 3, means the oxidation numbers of irons are plus 2 and plus 3, or it may be given average, that is 8/3. Okay. Let's see the question number 15. The oxidation state of iodine in ICl2 minus ion. So X, so 2 oxygens minus 1. So overall there is so oxidation number of iodine is +1. We know that the 17th group elements also shows +1, +5, +3, +7, and its common oxidation number -1. 17th group elements common oxidation number -1, but in the rare cases they also shows positive oxidation number. That is what are the positive oxidation number can be exhibited by these 17th group elements are +1, +3, +5, +7. That's it. Let's see the question number 16. The oxidation state of molybdenum again. Molybdenum in the compound given MO2Cl8 minus 4 ion is how much? There is no difference, just 2x. Each here carries -1, so -8 equals to -4. Overall charge, so -4. The 2x equals +4. And small molecule having +2 oxidation state. Next, see the important one, question number 2. Sorry, question number 20. Not question number 2. This is question number 20. So question number 20, there is a three atoms are given in a compound ABC, and it is given their oxidation states. So it is just have to do the problems like the first problem. Okay, with the help of options, you have to do the calculation. So try to do that. Next point, the last one. in the worksheet 3, the oxidation number of the oxidation number and covalency of sulfur in SO8 molecule. So I have to find the two questions here. We have to find the oxidation number and also the covalency. Covalency means nothing but it is the concept belongs to covalent bonds. Its concept belongs to covalent bonds. In ionic bonds, the belonging concept is electrovalency. Covalency concept belongs to covalent bond formation concept. So what is the covalence mean? The number of covalent bonds formed by an atom. The number of covalent bonds formed by an atom in the molecule formation is called its covalency. Now we see what is the oxidation number. Already we know oxidation number of SO8, oxidation number of sulfur in SO8 equals 0. Oxidation because all are free element covered. This is the first answer. What is the covalency? So covalency is equal to 2. So how the covalency 2 means here sulfur is having 2 bonds with other 2 sulfurs. Actually the sulfur structure is like this. So there is a crown type of structure is there. So here it is like this. So like this sulfur is having a crown type of structure in which each sulfur having bonds 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is called crown structure. Crown structure of SO8. Okay, here each sulfur is connecting with the other 2 sulfur atoms. Means each sulfur is having 2 bonds around it. That's why its covalency is 2. Free elements carbon, its oxidation number is 0. Okay. So here some more important questions are there. So actually what is the question is, actually it is the question number 9, the oxidation number worksheet 1. So what is the oxidation state of a most electronegative element? Oxidation number of most electronegative element in the products formed in the reaction of barium peroxide. Okay, barium peroxide and sulfuric acid. This means here we have to know about reaction also. Here what is the reaction is so barium peroxide reacts with H2SO4. So very simple, it forms barium sulfate and hydrogen peroxide. And this is also one of the best laboratory method to prepare hydrogen peroxide. That is barium peroxide changed to hydrogen peroxide, forming hydrogen peroxide. Here we have to find the oxidation number of most electronegative element in the products. There are 2 products are there. So what are the products? Barium sulfate and hydrogen peroxide. We have to calculate the most electronegative element in it. What is the most electronegative elements in the given compounds? That is oxygen. Okay. Here what is the oxygen oxidation number? Take +2. Barium +2, sulfur +6. We have to take 4x overall compound 0. So each oxygen having -2 oxidation number. And the peroxide. Peroxide means oxygen shows -1 oxidation number. So with help of calculation also we can do. So each hydrogen is 1, is 2x, and each oxygen having -1. So means oxygen shows -2 in BaSO4, -1 in hydrogen peroxide. In any peroxide shows -1 only. Okay. So next, the one more question was there in the worksheet 1, in the oxidation number 1 worksheet. That is there is 1 mole of, so it is given 1 mole of hydrogen. This is known as N2H4. Actually, general the reaction will be written as NH2 hydrogen. So 1 mole of this compound loses 10 mole of electrons. 10 mole of electrons to form a new compound. To form a new compound Y. So it is not given any information about Y, but we have to find the oxidation state of nitrogen in Y. Okay, just it's a very simple. Here first, what is the initial compound? Initial compound is hydrogen. So N2H4 is called hydrogen. Okay. What is the oxidation number of nitrogen in this compound? So to know the final oxidation number, we must know the initial oxidation number also, because we don't know what is the exact formula of the compound. So 2x. So x equal to -2 means here each nitrogen is having -2 oxidation number initially. Okay. Initial oxidation state of nitrogen, that is x equal to -2. Then what is we have to go for final oxidation number? If for final oxidation number, the clue is given. It is formed by losing 10 mole of electrons. 10 mole of it loses 1 mole of it compound loses 10 mole of electrons. So means we can write after losing 10 mole of electrons. 10 mole of electrons losing means actually in this compound gaining of electrons or losing electrons takes place only by nitrogen. Only by nitrogen. So hydrogen in the reactants, in the products, the oxidation number of hydrogen always +1. Means whatever the electrons gained or lost only by nitrogen. Here it is given it loses 10 moles of electron. Means the 10 moles of electrons are lost by 1 mole of this compound. Means 2 nitrogens combined loses 10 electrons. Loses 10 electrons by nitrogen atoms combinedly. Okay. So therefore, what will be the charge? Actually, what is the general charge initially? Nitrogen having -2. Each nitrogen having -2. So one nitrogen -2 position, second nitrogen -2. So they combinedly loses how many electrons? 10 electrons. 10 electron losing means what is the increase in the oxidation number? So we know that by losing the electrons, for every losing of 1 electron, the oxidation number increases by +1. 1 electron loses +1, 2 electron loses +2. Here 10 electrons loses means +10. So the +10 is, so -2 is the +5. Here 1 nitrogen also becomes -2 to +5. Okay. So the nitrogen oxidation, final oxidation state of nitrogen is N plus 3 and N plus 3. Means that the two nitrogens are present in N plus 3. Let's see, one more problem is there. So what is the oxidation state? So it is question number 36, I think in the worksheet 2. The oxidation number worksheet 2 is question number 36. There is a phosphorus has the oxidation state of +3 in which of the following compounds? So actually it's a very easy one, but we have to remember the formulas. Okay, so we go through with the options. The first one, phosphorus acid. Phosphorus acid, we know that is H3PO3. Next, orthophosphoric acid. It is also known as simple phosphoric acid also. So the formula is H3PO4. Next important one, metaphosphoric acid. That is HPO3. Next it is given hypophosphoric acid. That is H4O6P2. We have to know these formulas. So then it becomes easy to find the oxidation numbers. So first see the first one, H3PO3. So I think now you can do the problem. So 3 plus X minus 6. Here what is the oxidation number? So X equal to 3. Okay. So I think it is the answer. Phosphorus acid. In phosphorus acid, phosphorus is having +3. So we check the others also. In H3PO4, 3 plus X minus 8 equals 0. So phosphorus is having +5 oxidation number. Now we check here also, because in some questions multiple answers are also there. So -6 equals 0. X is having +5 oxidation number. So H4 here, 4 plus 6, each carries -1 there, it's -2. Plus 2x equals 0. Okay. So here x equal to 4. So phosphorus having total different oxidation number, that is 4. Means the answer is phosphorus acid H3PO3. Here important, see the structure of H4P6O2 having importance in the many problems. What is the structure is so P4. So we try to write the structure. Okay, so we're having OH, O6 are there. So maybe it is having the peroxy bond. We tried P4, H4, P2O6. I think it is having one peroxy bond, not one. So I have to get P2, so it is also not possible. So we try to get the structure. So 2 phosphorus. So you know that the minimum one double bond oxide should be there. So H4, I think. So this is the structure of this is for the H4P2O6. So if you know, already we know how to calculate the individual oxidation numbers in the given structure. The phosphorus having PP bonds cannot be counted, because if the bond is formed between the atoms of same element, there is no gaining, no losing. there is no charge will be formed on the atoms. Means the pp bond is countless. Now each particle is having how many bonds? 1, 2, 3, 4. So therefore its oxidation number is 4. Again these particles also having 1, 2, 3, 4. Okay. So means both are having plus 4 oxidation number, 4 and 4 oxidation state. Means only this is having oxidation number 3. Next, so these are the different examples in the oxidation worksheet 1, 2, 3. So there is some different examples are also there in our given class that questions on oxidation number class was there. It has many other examples are also there. If possible, you have to try. If possible not, you have to try again to that video also. Okay.